What abilities have humans lost during the course of evolution? First is the baculum, which, as the name suggests, is a bone found in the penis. It's standard among mammals. 98% of mammals in nature have it, but we humans do not. Animals all have fixed mating seasons. If they don't seize the opportunity to reproduce during this period, they'll have to wait another year. The baculum helps males mate with more females within this limited time, thereby increasing reproductive efficiency. However, modern human genome analysis shows that the baculum was still common in humans about 6 million years ago, but completely disappeared from our genes around 700,000 years ago. In other words, we had this powerful equipment during the beta test phase of Earth Online, but it was removed by the time the official release came out. Of course, this wasn't the server secretly altering our data, but rather there must have been some evolutionary advantage to losing the baculum. One theory suggests that when we began to walk upright, our body shape became completely different from that of animals. At its time, the nail bone will affect efficiency of movement, making people not good at running. If they fall accidentally, they are prone to fractures, increasing the risk of injury. So for a species like humans, who need to run and hunt, losing the baculum actually became an advantage. Moreover, humans are animals that are sexually receptive all year round, without a fixed mating season, so when it comes to reproduction, there's no urgency about missing a chance and having to wait another year. So it's no big deal if we don't have this bone. Take the palmaris longus muscle, for example. Stretch out your hand and pinch your thumb and little finger together. If you see a prominent bulge, that's the palmaris longus. Ancient apes used it to climb tree branches, but nowadays, about 15% of people no longer have this muscle, and among Asians, the proportion is as high as 30%. If you don't have it, there's no need to worry, it won't affect your grip strength at all. In fact, it just means you've evolved more completely. The loss of the fibella and the palmaris longus are both visible changes, but there are also some invisible losses, such as the liver's ability to synthesize vitamin C. Most non-primate mammal cows, sheep, horses, donkeys, and even the echidna are able to synthesize vitamin C on their own. However, most primates, including humans, have lost the ability to produce vitamin C and must obtain it from food. Around 60 million years ago, when the ancestors of humans were still primitive rodents, the gulo gene on our chromosome 8 mutated, became inactive, and stopped being expressed. So if you were to open the update log for Earth Online from 60 million years ago, you would definitely find a line like this. We have removed the active skill of vitamin C synthesis from some primitive rodents, weakening their ability to survive at sea. As everyone knows, vitamin C is one of the essential nutrients for the human body. Sailors during the Middle Ages, Caribbean pirates, and female pirates often developed scurvy from being at sea for long periods, unable to eat fresh vegetables and lacking vitamin C. So what should we modern humans do if we lack vitamin C? Of course, we should eat more fresh fruits and vegetables. So here's the question. Isn't evolution supposed to help us better adapt to our environment? How come it seems like the more we evolve, the weaker we get? Actually, that's not the case. 60 million years ago, fruit-bearing plants on Earth were already becoming increasingly abundant, so it wasn't difficult for those early rodents to get vitamin C from fruit. Plus, synthesizing vitamin C in the liver uses glucose as a raw material, which is very energy intensive. When vitamin C is readily available in the environment and making it yourself consumes a lot of energy, losing this ability actually becomes a survival advantage. Isn't it better to use the saved energy for something more meaningful, like reproducing or developing a bigger brain, for example? So although this hidden change seems like a downgrade, it's actually an upgrade. Another example. About 70 million years ago, the UX gene on human chromosome 1 became inactive. This gene is responsible for producing uricase, an enzyme that breaks down uric acid. Without uricase, the uric acid levels in our modern human blood are nearly 10 times higher than those of other mammals. See, no wonder lions and tigers eat animal organs every day. The purine content is so high, yet they never get gout. Of course, it's also possible that they just can't talk, so even if they did get gout, they wouldn't be able to tell us. The fact that our bodies have higher uric acid levels also seems like a disadvantage, but in reality, it's actually an advantage. Uric acid can stimulate fructose to be converted into fat more efficiently. In ancient times, when food was scarce, storing more fat meant having a better chance of survival. This was an evolutionary advantage. In other words, although modern humans come in all shapes and sizes, some weighing over 200 jin, some over 100 jin compared to the bipedal creatures from 17 million years ago, we're all much fatter by several times. Even though high uric acid can also cause gout. Does that really matter? Back then, our ancestors didn't even live long enough to get gout. Having a bit more fat was actually more likely to save their lives. Besides, could our genes have possibly predicted that 17 million years later, these little skinny monkeys would live to an average age of over 70? There are actually many other abilities that humans have lost during evolution. Most mammals can move their ears to pinpoint the source of a sound, helping them avoid being ambushed by predators. Although humans still have the three auricular muscles, most people have lost the ability to control them. Only a small number of people can actually move these muscles. Our wisdom teeth have lost their function of chewing plant roots, and the appendix has lost its ability to digest cellulose. Nowadays, the two of them are basically just useless organs. It's precisely these evolutionary remnants that constantly remind us that our bodies are products of evolution, not creations of some old man with a white beard.